So 6.1 was all about finding real roots. We talked about how you do not use plus or minus unless we are solving an equation or you are asked for the real roots. Remember, real roots is just another way of asking for solutions. So 6.1 sometimes asks for real roots, so we will use plus or minus on those. 6.2 was simplifying only, though, so they never showed up on that. So last chapter we worked on solving equations by maybe taking the square root of both sides, and we would get that here x was equal to plus or minus 4. Another way they could ask that is to find the real roots of 16. So here's just kind of some examples. So the real roots of 25 is plus or minus 5. Cube root of negative 27 would be negative 3. Fourth root of 16, since it's an even power, we'd want that plus or minus. That would be 2. Now, the fourth root of a negative 16 has no real roots because we cannot find real roots for a negative number to an even index. This one, though, however, is the square root of 49, which would be plus or minus. And then there's a negative out front. So basically saying if there's a negative out front, we can still take the square root of that number because it's positive. And it still would end up being plus or minus. I mean, I guess you could put minus plus, but it'd still just be plus or minus 7. And that's if they're asking for the real roots. If they just say simplify, like 6.2 does, you won't see plus or minus show up. All right? So in 6.2, all we are doing is simplifying, not finding real roots, so no plus or minuses should show up. And there's two scenarios, and it was all revolved around having the same index. So if we have the same index and we are multiplying or dividing, we can multiply or divide the radicands first before simplifying the root. So on this one, they're both cube root, so I can multiply these guys together and put them all under one big cube root, which would give me 250 x to the fourth y squared, and then a z to the sixth, because I've got z to the fifth here and z there. And then once we combine it, we can simplify it from there by looking for perfect cube within 250, which would be 125 and 2. So I'll be cube rooting that to get a 5. So I've got my 5 out front. So let's now look at the x's. This x could break down into a group of 3 and a group of 1. And then this group of 3 can escape once to match our index of 3. So an x is going to be left over. Y squared can't make it out at all. And then z would be able to form two groups of 3 z's. And then those could make it out twice. So on the outside, we'll have that highlighted group of 3 x's. X makes it out once. Y doesn't make it out at all. Both these groups of z make it out. So then still within the cube root is this 2, and this x, and this y squared. All right, and then that would be our final answer. And you know that would be it because there's no more cube roots within our cube root. All right, so over here we can do division first. This is a square root. So we could take this 128 divided by 2 is 64. And then we get an x to the fourth, a y cubed. Invisible index of 2 out here. 64 is a perfect square for 8. X to the fourth, I could take 2 groups out with none left over. For the y here, though, it'd be y times y. So I could take 1 y out, but I'd have a y left over. So the only thing left over in this case is that y. Okay, so we saw we did the division first to simplify it down to one radical, and then went from there. Rationalizing the denominator. And so this is when division can't simplify everything down to one root. So we're going to want to multiply by the denominator radicand by its missing pieces. It needs to match the index to the closest multiple. And then we also have to do it to the numerator. So like on one like this, this would be an easy one, would be square root of 5 and square root of 5. And that's because our index is 2. This is 5 to the first power, so I'm going to bring another 5 to the first power so that these would become 5 squared, being able to escape. And we're multiplying here, so we'd have a 5, and then up top I'd have square root of 5y. All right, cannot cancel those 5's. One's under a root and one is not. Here our index is to the 4th power. So we're going to want to get everybody to the 4th power. So that 5 is missing an exponent of 3. X is missing an exponent of 1. All right, and then when we multiply across, that'll get the x. We'll get a 5 to the 4th and x to the 4th, freeing up both of those because they're under a cube root. And then up top, I'd have the 5 cubes, 125 times 2 would get us to 250. And then x times x is x squared. All that stuff's still under the 4th root, though. And then that one would be finished. There's no 4th roots in 250. And then last one here, we've got a cube root scenario. So we need a 7 squared to match up with the 7 to the first. I need 1y. So z, I just need to get it to the next closest multiple, which would be z to the 6th. So I'm going to bring in 1z. Okay, so the denominator here, I'd get 7 cubed, y cubed, z to the 6th. So what's going to come out in its denominator, a little different than what we've seen so far. 7 makes it out once, the y makes it out once, the z makes it out twice, because it's to the 6th power. And then up top, we've got 7 squared is 49. So then we'll have to do 49 times 3, which would be 147. And then we have y, z squared, all of that to the cube root there.